Have you ever been low on battery, but your cord just wasn't quite long enough? Typically, a charging cord is about 3 feet in length, which means you are stuck within 3 feet of a wall. With wireless power transfer, you will never need to plug in again. As college students, we rely on rechargeable devices, but their charging cords can be a huge inconvenience. Cords get tangled, aren't long enough, and can fray over time. With wireless charging, these issues are non-existent. Wireless power transfer can be compared to starting a vehicle remotely. Today, I'm going to discuss the 3 steps of wireless power transfer and how they can be compared to the 3 steps of starting your vehicle remotely. The first step is power generation and the clicking of a key fob. The second step is the energy traveling, which is similar to the signal from the key fob traveling. The third step the third step is the catch and conversion of the energy into electric current, which can be compared to the receiver in your vehicle catching the signal and starting your car. I will begin by discussing the first step of these processes. The power source of the system is like the key fob for your vehicle. The power source generates the energy to be transmitted, which is similar to the key fob creating the signal to be sent to your vehicle. According to Chapter 6 of Biosensors and Bioelectronics, the power source is a transmission coil that generates a time-varying magnetic field. Just as clicking the key fob with a specific button a specific number of times creates the signal to send to your vehicle, stated by Russ Heaps, automotive writer. Now that we have discussed the first step of these processes, let's move on to the second step. The second step is the energy traveling over electromagnetic waves, which can be compared to the signal from the key fob traveling over radio waves. The energy in the form of time-varying magnetic fields travels in the space between coils over electromagnetic waves, according to Michigan Technological University. Just as the signal travels through the air over radio waves to the remote starter in your vehicle. The key fob and remote starter must be set to the same frequency in order to communicate, as stated by Russ Heaps. Now that we've discussed the second step, let's move on to the third step of these processes. The third step is the receiver coil capturing and converting the energy field into electric current, which is compared to the receiving the signal and starting your car. The receiver coil capturing the energy is the same as the control module in the remote starter receiving the signal. Both the receiver coil and the control module obtain the element needed to complete the final step of the processes. The conversion of the energy field into electric current can be compared to the ignition sequence being triggered by the control module. The time-varying magnetic field induces a voltage which flows through the coil as a current. Similarly, the signal being received by the control module instructs the remote starter to start your car, as stated by Jessica Choksi, writer for JD Power. The current flow in the receiver coil and the engine starting are the completion of the processes. Now that we have discussed today we've discussed the 3 steps of wireless power transfer and remotely starting your vehicle. Wirelessly transferring power can be compared to remotely starting your vehicle. The 3 steps of wireless power transfer are power generation, the energy traveling, and that energy being captured and converted into electrical current. These steps are compared to the 3 steps of remotely starting your vehicle, which are clicking the key fob, the signal traveling from the key fob to the vehicle, and the signal being caught and the car being started. These technologies have been innovated to a point where no physical contact is required. Now imagine a world without tangled cords and never having to find an outlet again. Thank you.